I predict that wireless charging is no longer a question of if, it's a question of when. And I think we're going to see it roll out in the next 3 to 5 years across Europe and the US.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Welcome to another edition of the Insider's Guide to Energy EV series. I'm your host, Chris Sass. With me is my co-host, Niall Riddell. Niall, we are going back to charging and charging in a way we haven't seen before. What is this episode about?
So we're going to talk a little bit about wireless charging. And wireless charging comes in a variety of shapes and sizes. Obviously, it doesn't have wires. But understanding exactly how we do that and whether it's something that's going to be on the roads tomorrow or whether it's something we need to wait a little bit longer for is going to be the topic of today's show. So I'm delighted that we have Charlie Levine from Electreon with us. Charlie, why don't you tell us a bit more about wireless charging?
Sure. Thanks for having me, first of all, both of you. Nice to be here. So wireless charging is just that, and I think you touched upon it pretty well. It's the absence of cables, wires, anything that connects physically to the vehicle to charge. So it's using inductive technology. It works similarly to your stove that you might have at home or your wireless charging electric toothbrush, where we're looking for magnetic coupling between two receivers. One is underneath the ground, either under the parked area or under the road. And then the other one is a receiver that's attached to the vehicle, the chassis of the vehicle. And then when the two match up, there's coupling between them and energy is transferred between the two.
And for my benefit, one of the things that we traditionally talk about is sort of static wireless charging. You drive over a pad and you have to line it up perfectly. And after that, you start a wireless charging session. But I believe you guys are doing quite a lot of work looking at dynamic wireless charging as well. Can you explain a bit more about the pros and cons of those two approaches?
Sure, absolutely. So starting with the stationary wireless charging or the static charging, like you mentioned, there is a question about the misalignment tolerance. So how far can you move in either direction, either to the side or backwards and forwards before you have an issue with charging? Our system is pretty robust to misalignment. And so you've constantly got this up to 40 centimeters in either direction. Question. It's quite a lot.
Yeah, it's quite a lot
when you think about it. And it also depends on the vehicle itself that's charging. So go ahead.
And do you therefore have to have some specific camera underneath or some alignment technology, or do you just go, it's roughly in the parking spot?
It's roughly in the parking spot. I'm afraid we're pretty old school. We're for the parking spot, we're using painted strips on the floor.
Now, I know that most vehicles have bumper height restrictions and clearance. So how does the gap from the bottom of the vehicle to the charging plate work? Do you need to do something automated? Does it need to drop down, or can it handle this blank space between it?
So it depends on the vehicle itself. So with a passenger vehicle, not required. We're looking at directly under the chassis, attached or built in, depending on the vehicle itself. And with the larger vehicles, the heavy duty trucks, the buses, we are in some cases looking at a drop down system like you described, where there's hydraulic system and it lowers down to initiate the charging. So,
and clearly this then varies when you do something dynamically, because all of a sudden you've got moving vehicle over a static wireless transmitter. How do you manage that? Is it all about getting perfect alignment? Do you need autonomous vehicles, or is this just drive down the middle of the road and everything happens like magic?
I mean, you've pretty much described it in an excellent marketeeringly way. So just driving straight in a straight enough line, as we described with the stationary wireless charging, we do have pretty high tolerance to misalignment, and it's pretty much the same. So when we think about it, it's an ideal use case with autonomous vehicles, simply because they're easier to control. But it's not entirely necessary.
When I think you talk about magnetic fields and stuff, I think of electromagnetic pulses and things. And an EV is pretty much a computer on wheels, for lack of a better term, with a couple of electric motors. I guess what I want to know is, does it impact the electronics? Or if I'm on my cell phone next to where you're charging, am I still going to be on my cell phone right at the charging station while I'm refueling?
Yep, absolutely. So we've done a lot of electromagnetic compatibility testing, and making sure we adhere to the strictest standards. Of course, it's a huge topic. You're not the first to ask. It comes up quite a lot. And we make sure that there's no impacts to the surrounding environment. In fact, we have one project. It's in Gotland in Sweden, on an island there, and it's right next to an airport. And there they have a particular worry about EMC. And so we made sure that everything adhered to the highest standards there, and with the army as well. They also had a base right next door, and they did some testing.
So if I can ask the naive question, what's the point? It feels like you can plug in a cable in like under 30 seconds. Surely wireless charging is just for lazy people, or is there some additional hidden benefit that we've not covered?
So now you, Chris, and myself can all charge in one vehicle by ourselves. That doesn't seem like too much of a hassle. But when we think about, first of all, what's been up until now, it's been a transition between anything that was plug-in, like the Ethernet cables for the internet back in the day, and then the transition slowly to wireless when the technology was good, stable, and could enable such a transition. So when we think about fleets, when we think about fleets, for example, we have an issue with needing to have many people to charge the vehicles or to plug in the vehicles simultaneously, and we have an issue around the overnight charging, the grid connection required, how large is the connection, how long does it take to bring the energy to the site, and of course the size, weight, environmental impacts and cost of the vehicle batteries at scale. So
So
those are
then,
huge issues that wireless charging solves.
so then you can take the cables out of the depot. You can make it easier for your bus drivers who probably just forget to plug in to be able to, drive over their allocated parking slot, plug in at night, charge up, or while they're out on the road, pick up a charge. So you can start to see there's a use case in here around particularly commercial vehicles. But then the question that obviously follows is how efficient is that energy transfer between a pad and the vehicle? Are we in a place where we actually get a reasonable level of efficiency?
Oh, absolutely. So when we're in stationary wireless charging, we can get up to 92, 93% efficiency, which is pretty comparable to plug-in charging with long cables,
Yeah.
and around 85% to 87% with dynamic wireless charging when the vehicle's driving.
Was there a technology change or something that happened to make this interesting now? I mean, EVs, although they've been all the rage in the news and getting more mainstream, we've had battery tech and electric vehicles for some period of time now. Why are we talking wireless charging today?
Great question, Chris. I think that when we think about this technology, it's definitely an evolution rather than a revolution. Whenever you talk about anything to do with infrastructure, we're not saying something is going to happen tomorrow and then it's going to be everywhere all at once. We're thinking about a rollout that makes sense. And I think that there's more and more interest through a few of the projects that we're doing and some of the competitors in the industry are doing as well.
So we can see that this technology is coming. Have you got live projects today? Is it rolled out widely, or is it limited trials that we're still scaling up?
So we've got around 20 different projects around Sweden, the Nordics, Germany, France. We have a project coming up. It's in the middle of being deployed now, actually, so it will be operational by the middle of this year. And we have projects in Israel and several operational projects in the US too, all with a variety of use cases and vehicles.
These projects, as you've gone in the early, I don't know if they're alpha or beta type projects, what was the permitting process like? Because it's a new technology. So are the communities ready to install this kind of technology and other requirements in the regulation keeping up with the technology?
That's a good point. I think that's probably the area that's trickiest for us. Not necessarily the development of the technology at this phase, the stage when we see that it's ready for market and it's in its commercialization phase. I think that the challenge here is about getting the the authorities on board. And of course, that differs not only from country to country, but state to state, and sometimes locale to locale, depending on who's the commissioning body there. And we couldn't do that without the relationship with our partners that we have. So, we're the technology provider, but when we're thinking about an ecosystem change like this, or such a dramatic change to the infrastructure, we're working with dozens of partners, including energy companies and providers, road construction, engineering, OEMs. So it's really a group effort required, especially on the automotive side we're seeing today.
Who are the first users willing to take this test? Are energy companies looking to try it and proof of concept it, or where are the kind of users who want to be your alphas?
So on the energy side, yes, the energy providers, they're super interested to see how does it work, especially when we look at battery and energy storage as well. How does that work together, and how does it all couple with renewables? Because we've done several projects like the one I was beginning to tell you about in Gotland and Sweden, where we showed solar panels on site there that was charging the system directly with battery storage device. And we're seeing also on the vehicle side a lot of interest, and from fleets, commercial and public transit fleets. So together, the three prongs are all pushing towards the same direction.
And that Gotland project, as an example, how big is it? Is it one small 7 kilowatt charger, or is it multiple locations, multiple bays, multiple vehicles? How big are these projects now becoming?
So Gotland was the world's first wireless electric road on a public road. It was just over a mile long, with also stationary wireless charging. And there we wanted to demonstrate a 12-meter electric bus and a 40-ton electric truck charging from the same system simultaneously with reduced battery capacity. So that's on the small side. We have a few other small projects on that scale. And then it's scaling up to fully commercial projects, like in Israel, for example, where we have a charging of up to 30 buses at a bus depot, all happening simultaneously.
What are the economics of doing this? You just talked about a mile of road. What does that do compared to a charging network as we think of today? What are the economics of building this into the infrastructure as opposed to putting in a charging station, as we know?
Okay, so when you put in 100 meters of wireless electric road, you get up to 15 charging spots depending on the vehicles. So say we're targeting the price of around $750,000 to $800,000 per kilometer, then when you compare it, it's like the cost of fast charging, or even less, depending on where you're putting the infrastructure. So what we're working really hard with our partners today is how do we make the system even more cost efficient and scale up and reduce costs in manufacturing.
But if you're traveling at 60 miles an hour, I assume there's some speed that this is optimal at, that it works better. In 100 meters, I mean, you need a whole lot of road to get a full, a 20-minute quick charge or whatever, right? I mean, you're going to need a lot of road. So is that math really a direct correlation? Because I mean, you can have 15 vehicles, but for like a blip at 100 meters.
Right. And that's a good point, and there is an optimum point at which traveling speed and how many vehicles you've got bumper to bumper on the system really makes a lot of sense. So what we look at to begin with is use cases where the vehicle drives the same route or fixed route, and they're driving slowly. So in busy areas where urban centers, for example, or if we were looking at traffic lights where they stop, that's ideal for us because it isn't an issue of how much energy we can transfer. Right now we're working on 70 kilowatts per receiver, and a passenger vehicle has one receiver, a van has two, and other vehicles can have 3, 4, or 5 depending on the length of the vehicle. So that's not the issue. It's about where's the sweet spot in terms of location, where to strategically put these wireless charging stations, and how much time are the vehicles going to spend on those systems that we deploy.
I was going to say, are you leaning more towards then the road, like the Buck Rogers kind of future where we're just driving along and our car automatically charges, or are the pad solutions more of an early interest where I have a fleet and I know that, the example Neil gave, I bring my bus into the depot it's got a few hours downtime and it just pulls in and it just happens to charge. There's no intervention needed.
So I think we're looking at all of the use cases simultaneously, to make sure that we understand exactly where is the greatest benefit for the greatest number of users. So the bus, we've pretty much got down the bus use case, whether it's a BRT, an urban bus, or a bus that drives for longer distances. We've got a good sense about how to deploy the technology for those vehicles. For example, we've got a system operational where we've got end terminal or end station and first station wireless charging stations, so static charging. And then we've got around 14% of the line electrified. And that's enough to provide 24-hour power for the vehicle to drive without stopping. I mean, it has to. The driver has to stop eventually, but he or she need not. And then any use case where it's clear where the vehicle drives and how long the vehicle drives for, it's pretty easy for us. But what we're working on in parallel with Toyota and Denso is home wireless charging kits. So what we think we're going to see is slowly through 2025 and 2026 is more and more users who are interested in using the systems at home. And then in the geographies where we have projects, being able to not only have the wireless charging at home, but be able to use the dynamic wireless charging along their routes, on their daily routes.
So if I was to bring this together, when we started this conversation, I mentally had this idea of a BMW, because they rolled one out very early on, pulling up on a driveway and charging at home at 7 kilowatts overnight. What we've actually just described is the ability for large commercial vehicles to deploy multiple receivers onto the vehicle and to pull up into slow-moving traffic at a roundabout or a traffic light and dwell as they approach that slow-moving chunk of road. They travel over it slowly with 3 or 4 receivers at 70 kilowatts each. They might be on that for a couple of minutes as they pull through that section of road. But with 4 receivers, they could be pulling 140, 280 kilowatts, which is a sizable chunk of load. You put 2 or 3 of those traffic lights on their regular route, and before you know it, like you say, they might not need to stop.
That's pretty much it. And of course, there's a sweet spot. The only limiting factor then becomes grid capacity that's available. So we might look at where is that? And I think it depends on the location, what in terms of energy is available, and B, what's the specific use case for the vehicle that's driving? How much energy does it actually need?
For me, that grid question is much easier now because if you correlate spare grid capacity to truck stops, it's probably quite limited. Whereas if you correlate roundabouts that trucks drive through to spare grid capacity, there's a lot more opportunities to charge. So actually, this gives a lot more flexibility to grid operators around where they put high-powered connections for charging electric vehicles.
Exactly.
So that neatly moves us to the next question, which is why Electreon? Why you guys? What's made you special and what's enabled you to get a front foot on this marketplace?
I think the other companies that are involved in wireless charging for electric vehicles started with stationary wireless charging first. Electreon started with dynamic wireless charging and then worked backwards. And it looks like, from what we're seeing on the market, that it's easier to do that than it is to go the other way around. I think also the company was founded by 2 guys that came from the aerospace industries with a specific vision back in 2011, 2012 to try to do something about the fact that we were heading towards high power charging and massive batteries. And, their ultimate goal is to reduce the size of the batteries, reduce the power required, and keep the vehicle stock in operation for as long as possible. So big sustainability element to that then.
And where's the company today? How many employees and how big are you?
Today we're 135 employees with plans to grow quite significantly in the next few years. I think the partnerships that we briefly touched on earlier are incredibly important to us. So we're working with automotives like Toyota, Ford, Stellantis, Iveco, and many others. And I think that's crucial to our rollout plan and strategy. And And I think, the mentality that we have of still being a startup, even though it's a publicly traded company at this point on the Tel Aviv Stock Exchange, allows us to move fast and break things and then quickly go back to the drawing board. So I think some of the other companies who have been maybe more intertwined with the automotives from the beginning or from the get-go or from the larger industry players haven't been able to move as quickly as we have.
And I didn't notice Tesla mentioned in your conversation. What is Tesla's strategy for this? Obviously, if you're looking at the market, you kind of have a good feel what people are doing. What do they appear to be doing, at least from the outside?
So it looks like they're looking at stationary wireless charging for home, the home use case or the home charger market. It looks like they'll be targeting the high end of the passenger vehicles. And other than that, your guess is as good as mine. I only know what we read on the in the news. Who knows?
How about BYD? Are they embracing this technology?
I think BYD is an excellent example of a company that's moving incredibly fast. And they're looking at and exploring a whole range of technologies that could power it. But ultimately, it comes from the place of what's desired on the market. So I think as there's more and more awareness of this technology, more end users, more fleet customers are going to want it, and that's going to drive demand.
All right, and Neil, I'm sorry, I'm going to steal the mic for one more second. I know Neil's dying to get in here, but as I'm listening to this, and you said something interesting. Is the initial concept was to have smaller batteries? So I'm thinking less resources, less worried about resources around the world. But I guess, what is that trade-off? So if I want to make miles and miles of highway charging capable, what kind of technology or what resources go into that as opposed to going into the batteries? So where's the saving? And Neil's saying less weight in the chat as well. He's pointing out that if you have smaller batteries, you're moving things around that are lighter. So if you're continually recharging, but I guess I just look at the mining or getting the resources to make all these batteries. How big a trade-off is that compared to electrifying roads?
So as I mentioned earlier, I don't think we're looking at a use case where we electrify thousands upon thousands of kilometers or miles of roads. I think that won't make sense because of the trade-off we're talking about with the assets that are required for it. But the system itself is pretty simple when we're thinking about what goes under the road or under the paved area. It's just copper and rubber. So when you look at that, there's no other minerals that are rare. There are no requirements on that side. So you see the massive reduction, and many studies have been conducted on wireless electric roads that are independent of us. And they're all coming back with the same results from their analysis, that when you look at the sustainability element, you are seeing a much better result.
So one of the key pieces in this is going to be your partnerships with vehicles, because obviously each of those vehicles needs to be modified with some kind of receiver. And I can see that for the commercial vehicle world, modification is a fairly standard part of practice. You change the body shape or whatever layout you've got for your vehicle and set it up the way you want. So, from that angle, do we see that this is going to be something easier to achieve with commercial vehicles than with passenger cars, for example, where people might not want to modify a passenger car?
We're not forcing this on anyone in any sense of the word. So I think, what we're going to see first on the passenger vehicle side is a select group of people that specifically want that technology. And so to retrofit a vehicle is a pretty simple process. Once we've worked with one vehicle, once we've worked with one model, it takes a few hours to retrofit that vehicle. And I'm sure as we do more, we can get much quicker at that, especially as we see the automation of and more robotics on that side. I think it's not a process that is too scary for the automotive side. That part looks interesting to them. But we're also working with Toyota on having vehicles come off the manufacturing line with the technology already embedded in.
Which feels like a really tidy solution, because you then go, yes, I want my silver paint finish and I want my wireless electric module, and you buy your new vehicle with both of those things integrated. But I'm assuming the way you described it, it feels like the retrofit is still quite straightforward. It's some screws, a dedicated plate, and some sort of DC wireless hookup inside the car.
Sure. So there's the mechanical, electrical CAN bus connection. So we have those, and it's something we've done dozens upon dozens of times now. So it's getting easier every time.
And then for something like an electric truck, because that's where I think this use case could get really exciting. You are doing very similar. You presumably use the tractor units rather than the trailer, and you integrate
No, we're
them.
looking at the trailer.
You put them on the trailer as well. So you can do
Yeah.
pickup for the full sort of 15, 16, 17 meters of length of a vehicle.
Yeah. So when we look at articulated vehicles, for example, technically there'd be no limitation to that.
And given the challenges there are in configuring batteries inside the axle arrangements of vehicles, because what you find is as soon as you've got 3 axles through a tractor unit, you've got less space for batteries. If you can replace the additional battery capacity with some receivers to enable you to extend the range of that vehicle, it suddenly makes the idea of an electric tractor unit really doing decent ranges quite viable.
Absolutely. And then we've got less weight on the vehicle side and less damage to the road, able to carry more payload. It's a win-win-win.
Yeah, we can start to see this use case really coming together quite nicely.
You briefly discovered a number of projects where you're at and where this is. So in the prelude to this call, I mentioned that we hadn't done a lot on wireless because most people don't think it's real. They think it's a pipe dream and it's really far away. We've done episodes in battery swapping. Once again, people are skeptical. So whenever there's new technology, people are skeptical. Where is this in reality? So I know you talked specifically as a company about some early projects. What's the rollout going to look like? And where are we going with this over the next little while?
Sure. So I think that throughout this year, and next year are going to be pretty pivotal for the company. And of course, other wireless charging providers are also available on the market. And we welcome competition as much as possible because the market's huge. It's endless. Everyone can get a piece of it. There's plenty to go around. I think we're going to see more and more projects roll out and expand. And I think, up until 2030, we could see a slow evolution, specifically in the countries that we mentioned earlier, Germany being a hub, Norway, Sweden, the US, Israel, potentially China. We have some relationships and projects going on there too, and Japan, especially with the support of Toyota and Denso.
This is very real and this is coming. You haven't mentioned the UK. I'm feeling very left out at the moment. Do you think we could see something in the UK as well?
So I think two major challenges with the UK. One, it's an island, and two, I don't know if you knew this about the UK, but it turns out it's an island. And second of all, I think since Brexit, the relationship has been pretty challenging, and we've done some studies together with Coventry, for example. The Coventry City Council was incredibly interested in this technology. And then there were too many questions. This was back in 2021, 2022. There were too many questions about what was going to happen with Brexit and how we were going to match up the technology with the rest of the European Union if we were going to match up. And I think we're going to see some challenges there. But, not only do we have the project partners all needing to come together and align, we also have the government support that we need. And so we're seeing a lot of government support in Europe coming out of Germany, France, Sweden, and we're not seeing as much support coming out of the UK. So, we have limited resources as a company and we have to focus on where the support is to begin with. So.
All right. To take that a little further, I'm just curious, is this a licensing model or are you owning and building this infrastructure?
Owning and building the infrastructure for now.
So you come into a municipality, you talked about talking to one in 21, 22, and you basically partner with them. Is there a revenue share with municipalities or folks, or how does that work?
So let's look at a really easy use case to see how that could work. So let's look at a toll road operator. So there we might look at a rev share. You're already consuming the road as the asset itself or as the resource. you come in, you look at adding wireless charging there for vehicles to use, and then you're adding an additional value that's created, and you can charge for that. By the way, we're looking at cost points similar to fast charging today. Not too much of a difference for the end user. And then for the municipalities, we have rev shares, or sometimes they're the end customer paying for the service. So, and as we think about rolling out further and further, we might look at build, operate, and transfer. These private-public partnerships that seem to be working for different infrastructures in a lot of locations.
I love this idea. So you're pulling down the toll road. You always try and go to the shortest queue, but suddenly you're going to go to the longest queue because you want to sit there and actually get a little bit of a charge while you're coming up to the toll booth. It's nice, slow-moving vehicles. You're ready to do it. You charge up, and then you're back out the other side, and you've got a little bit of extra range on that journey. But let's talk a bit about payment. I'm assuming everything has to be automated because you're driving down the road. If a company has installed your receivers and they've got a relationship with you, presumably it goes, "Hey, I'm an Electreon truck. Can I charge on the Electreon bit of road?" Whereas a competitor might be in the lane next to you and you take your Electreon truck down it and it wouldn't work. How do you recognize vehicles and enable that sort of like start and stop charging session to take place?
Okay. So I think the first point is, in the future, if you, Niall, or you, Chris, have your technology, whether or not it's a receiver provided by Whitetricity, it's a Tesla receiver or an Electreon receiver, in the future, you'll be able to charge from any infrastructure that's embedded in the roadway. I think that will be a must. We're seeing it coming out now as a requirement from the authorities, and rightly so. Ultimately, the value needs to be for the end users, and you don't need to, very similarly to how we work with OCPI and OCPP. So, you use roaming and you can use any of the operators that are available, and then you're billed at the end by your provider.
And that is my dream scenario, because suddenly you can give your driver the opportunity to plug in and charge when they go to a certain location, or drive down the road and pick up a wireless charge depending on where they're going. So it's great to hear that standardization is in your thinking. Charlie, you've taken us on quite a nice little journey through what is wireless charging. And like we said, this is the first time we've had an opportunity to dig into it through some of the real world projects that you've rolled right out there. And now into this actual, this is coming, guys. It's right there. Could I take the opportunity for one final question and ask you, what might be your prediction for the future for this technology? Where do you see this going, and how quickly do you see driver behavior changing as a consequence of this new technology arriving?
I would say that the next 5 years are critical. I think by 2030, we'll be in a completely different place. I think that we won't be having a conversation about if, when, and how. It will be becoming more accepted, both by fleets, commercial and public transit fleets, and both by the end user. And I think a few more years after that, people will come to expect it as standard within the system. Think about how the mobility world has changed. I just came back from Shanghai, and I was absolutely amazed by the amount of electric vehicles that are on the roads and the different experience, and then just the standard that you come to expect when you order a Didi taxi. So I think, we get used to change pretty quickly, and I think this is going to be the same.
Charlie, thank you ever so much for your time. I appreciate this, and I'm very much looking forward to my electric wireless charging future.
Thank you very much for having me both.
Audience, we hope you've enjoyed this content. It's been an interesting journey to find out what's on the horizon for wireless charging and what's about to come down. If you've enjoyed this content, please don't forget to share it with your friends. Do us a huge favor and subscribe, add comments, and like. That helps the podcast and it helps you get more amazing content like this. We'll see you next time on the Insider's Guide to Energy podcast. Bye for now.